All right, here we go. And this third rule, rather than just giving you the rule and then using it, I think it might be a little bit better for you if we can kind of demonstrate what the rule would have to be and then kind of write out explicitly what the rule itself is. So let's start with, and actually I'm going to give us a little more room. Let's start with G here. We have 2 to the log base 2 of 16 power. So that log base 2 of 16, that's actually the exponent itself. If you want to write kind of log base 2 of 16 as x, this is really saying 2 to the x power. That's what's going on here. That exponent is this whole log base 2 of 16. Now, let's think for a second if this was equal to, let's say, y. All right? Now, if we're going to rewrite this into exponential form, this would be log base 2, so base 2 of y, so y is equal to the exponent. And what is the exponent? Well, the exponent is log base 2 of 16. This is typically where the exponent is, just our exponent itself happens to also have a log in it. And now take a look at this equation. So we've got log base 2 of something equals log base 2 of 16. And at this point it's pretty clear, hey, whatever this something is, this y, it's got to be the same as this one here because the rest is all the same. It's log base 2 of some number is equal to log base 2 of some number. Those numbers must be the same. So our y value, what this whole thing is equal to, is 16. It is 16 here. Our answer here is 16. And so knowing that, let's kind of formalize our rule. If we have a base, b, to the log of that base to the of x, our result is just x. All right, so our result is x. If we have base to the log base b of x power, then that full thing will simplify down to just x. Knowing all that, hopefully we can look at h and go, oh, our answer must be 125. 125. But let's go ahead and show why that will be. Let's kind of reprove it one more time just to get the swing of things. So if I have 5 to the log base 5 of 125 power, then that, if I want to change that exponent, because this is exponential form, if I change that into logarithmic form, and let's just say for a second it's equal to y again, just for to make it a little bit clear, then we'll have log base 5 of y, so log base 5 of y is equal to the exponent. Now what is the exponent? Well, it's log base 5 of 125. And so whatever log base 5 of y is equal to log base 5 of 125, whatever these two numbers are, they've got to be the same. So our answer is 125. All right. And these next two you can reprove to yourself as well. And so we've got 4 to the log base 4 of x power, meaning, hey, I've got my base of 4 here, and then a log base 4. That means my answer is going to be the value at the end, which is x. So my answer here is just x. And even if it's a natural log, same thing going here. So I've got e to the natural log, which is log base e. Remember, natural log is the same thing as log base e. You just won't ever see it written that way. You'll always just see the ln, natural log. So e to the natural log of x. Well, what is my my value here at the end? That is going to be x again. X is my answer. All right. So looking back on this section, here's kind of these 3 rules, and getting a good grip on these would be a great idea for you. Remember that it's saying that, hey, if I have a log of base something equal to 1, that exponent has to be 0. That's the first rule. Next, I've got log of base something equals that something to the x power. Well, that's exactly what a logarithm is talking about. That's going to be my x as my result, whatever the exponent is. And lastly, if I have some number to a log power, if the bases are the same, then my result is the x in the exponent. So the of in the exponent. That'll be our answer. Hope that helps.